Okay, friends, going to come to you today. We're going to talk about adding and subtracting scientific notation. Now, yesterday in your journal, you took your notes. Now, the video probably gave you a different number in your journal and a different date. Just make sure yours is correct. It should have been number 13, and you did it on 10/5/20. All right, so today we're looking at adding and subtracting with scientific notation, and today is October 6th. All right, so page 14, adding and subtracting with scientific notation. Now, as always, as I'm writing the notes, you're writing the notes. Pause if you need to catch up if I write too quick. But everything should be in your journal that is in my journal. Okay? All right, so let's just start with the problem and see what this is going to look like. So let's say I have 2.4 times 10 to the third. So I've got that quantity plus 3.7 times 10 to the third. Now, yesterday we learned that really this is just another way, scientific notation is just another way to write these large numbers or tiny numbers in a different way so that we can work with them better. Okay. All right, so when we're adding or subtracting with scientific notation, make you a little note, your exponents, your power of 10, must match. Okay. So with this one, it does. I have 10 to the third and 10 to the third, so that's the same exponent. So at this point, I'm just going to regroup some things. So let's put our base numbers together. So 2.4 plus, because we're adding, 3.7. Okay. And then I'm just going to keep that times 10 to the power of 3. Okay, I won't have to worry about that. I'm just keeping that for my answer. All right, and then all I've got to do is add my two decimal numbers. Now remember, when we're adding with decimals, we line up the decimals. So I've got 2 4/10 plus 3 7/10. Line up your decimals. Now you do have to be neat about this. 4 7 is 11. Carry the 1. 2 3 is 5. Plus 1 more is 6. So my answer would be 6 1/10. So 6.1 times 10 to the third. We leave our answer in scientific notation unless we're asked to do otherwise, and that's it. I'm checking to see, yes, my decimal is in the correct spot. We said yesterday you can only have one digit to the left of the decimal, and it needs to be with a power of 10. So I'm through with that one. That's all I had to do. All right, let's try this one. Let's say I've got 3.1 times 10 to the fourth plus 2.4 times 10 to the fourth. Now, I want you to do a little bit of this one. I want you to pause the video, and I want you to regroup it, and then I want you to add your decimals, and then come back to the video and see if you did it correctly. All right, so you regrouped. You put 3.1 plus 2.4. The 4's match, so times 10 to the fourth. We're good there. We don't have to do anything. And then all I'm doing is adding my two decimal numbers. So 3.1 plus 2.4. 1 and 4 is 5. 3 and 2 is 5. So I have 5.5 times 10 to the fourth. Okay. All right. Easy, no problem. All right, now let's look at one where the exponents do not match and what we need to do. All right, so for number 3, let's have 2.4 times 10 to the fourth plus 1.7 times 10 to the third. Okay? Now, you can decide which way you want to go. Either I need to make both of the expressions have an exponent of 3, or I need to go to the 4. I like to make it to the bigger one, so I always say go big. It ends up saving you some work in the end. Okay? So if I need this exponent to become a 4, that means that I need to move the decimal one more place to the left. All right, so let's make a note. When you move the decimal to the left, your exponent increases. How many ever times you move that decimal is how many times the exponent will jump up. Okay, so let's go big. So that means we're going to keep the first one. And if I'm going to move this one to the left, okay, I'm just going to move it one time, so I would have 0.17 times 10 to the fourth. Now my exponents match. Now I'm ready to regroup. So I'm going to do 2.4 plus 0.17, and I'm keeping that times 10 to the fourth. Okay, going to add my digits, add my decimals. Remember, line up your decimals, so keep track of where your numbers are. You're adding. If you need to fill in a 0 there so that you can keep everything lined up. So we have 7, we have 5, and we have 2. So I would have 2.57 times 10 to the fourth. And that would be good. Okay, now that's with me making the exponents bigger. That's when I went big. Let's look at the same problem if I had decided to make the 4 into the 3, because I can do it either way and I'll still get the correct answer. But you'll see what happens sometimes when you go small. All right, so let's start with the same problem. 2.4 times 10 to the fourth plus 1.7 times 10 to the third. Okay. So this time I want this exponent to go down to a 3. So think about it. If you move the decimal to the left to increase, what's going to happen to the exponent? How are you going to make it decrease? If moving left increases, that means moving right decreases. So let's make a note of that. So when you move the decimal to the right, exponents decrease. Okay. So that means if I want this to become a 3, this decimal is going to have to back up to here. Sorry, I said that backwards. It's going to have to go to the right. So we're going to have 24 times 10 to the third plus 1.7 times 10 to the third. Now I'm ready to regroup. So I have 24 plus 1.7 times 10 to the third. Now I'm ready to add my decimals. Again, line up the decimals, and if you don't see the decimal, we moved it. We know where it's at. It's at the end. So I get 25.7 times 10 to the third. Now I have the same value as before, but look at my number. It's not written in scientific notation. Remember, the decimal has to be here. It has to be right after the first digit. You're looking for a number that is like 1 point, 2 point, 3 point, all the way up to like 9 point. Okay? 25 is too big. So I've got to move that decimal to the left. Well, we just set up here, when you move the decimal to the left, the exponent increases. So that means I'm going to have 2.57 times 10 to the 4th. Okay, so sometimes when you make your exponent smaller, that means you're going to have an extra step at the end because you're going to have to get that decimal back to where it should be. You always check that. Okay. All right, let's keep going. And let's try this one. Let's say I've got 3.2 times 10 to the 6th plus 2.4 times 10 to the 4th. Okay. Now, my exponents don't match, so I can either go big or I can go small. Let's go big. So that means this one is going to have to change. It needs to go from a 4 to a 6, and to make it go up 2 places, I'm moving that decimal to the left 2 places. So I'm going to keep the first one. So now I'm going to, if I move it 2 places to the left, I'm going to have to add a 0 and then my 2,4 times 10 to the 6th. Okay. Now, exponents match. Let's regroup. So I have 3.2 plus 0.024 times 10 to the 6th. All right, let's add them up. I'm going to use my space over here. So 3.2 plus 0.024, line up those decimals, fill in with 0 so you can see what's happening. So I have 3.224 times 10 to the 6th. Okay. All right, you did pretty good. Let's do a couple more. Let's do one with subtracting because we haven't done that yet. It works the same way. All right, and let's look at some negative exponents because we haven't done that either. All right, let's say I've got 8.9 times 10 to the negative 2 minus 3.4 times 10 to the negative 4. Okay. Exponents don't match. Now, if I want to go big, remember going big, they're negative, so negative 2 is bigger than negative 4, so that's where I'm going to go. All right, so I'm keeping this side, so 8.9 times 10 to the negative 2 minus, now to make this 2 digits bigger, I want it to get to negative 2, we're increasing, we move it to the left to increase, so I'm going to move it once, twice. So I'm going to have 0.034 times 10 to the negative 2. All right, now I can regroup. So I have 8.9. Now we're subtracting this time. 0.034 times 10 to the negative 2. All right, so I'm going to use some space over here. So 8.9 minus 0.034. Now you've got to add some zeros because remember when you're subtracting, we've lined up the decimals and we can't just say bring down the 3-4. Let's zoom it in here a little bit. You've got to borrow. All right, so I'm going to borrow from the 9, 8. That becomes, remember. All right, so now 10 minus 4 is 6. 9 minus 3 is 6, and 8 minus 0 is 8. So I have 8.866 times 10 to the negative 2. Okay, so it means I've got a little decimal number. Because remember, negative exponents mean you have a number between 0 and 1. All right, number 6. Let's make this is going to be our last one. So I've got 2.3 times 10 to the negative 3 plus 4.5 times 10 to the negative 4. All right, so let's go big. Negative 3 is your bigger, so that means this one's going to have to increase. To increase, we move it to the left one time. So I'm going to keep this one. And this is going to become 0.45 times 10 to the negative 3. All right, now we can regroup. So 2.3 plus 0.45 times 10 to the negative 3. All right, let's combine these. So 2.3 plus 0.45. So I have 2.75 times 10 to negative 3. My decimal's in the correct spot. I have a power of 10. All right, guys, that's the way it works for adding and subtracting with scientific notation. See you next time.